This video has been produced by Carno Metalbox Beverage Sector and Engineering Seaming Systems to promote the new double seam specification. This specification has been issued by the can makers through the Metal Packaging Members Association (MPMA) and adopted by CFEL, SEFEL, an equivalent body in Europe. You will see in this video the process of double seaming and the correct way to carry out a full seam check. In addition, the impact of the critical parameters on double seam integrity is discussed. As the can travels through the seamer, it passes a sensor. The no can no cover finger is then activated and an end is fed from the downstacker hopper into the end guides via a scroll. The knock-off pad moves down to lightly contact the end, and simultaneously the lifter rises and clamps the can and end into the seaming chuck. The first operation roll moves in. As the first operation roll moves in, the curl is kick-started and tucked up under the flange. To maintain a good seam, it is important to check the dimensions of the first operation at least once a week for the following parameters: first operation countersink depth, first operation seam thickness, and first operation seam length. Just after the peak of the first operation cam, the second operation roll moves in and the first operation roll moves away. The second operation roll moves in to tighten and complete the seam, thus forming a hermetic seal. Just after the peak of the second operation cam, the second operation roll moves away and the lifter descends, discharging the can. Two categories of parameters characterize a double seam: the critical parameters and the operating parameters. Seam thickness, tightness rating, actual overlap, body hook butting, and seam gap. These are the critical parameters. Nominal seam thickness is 3 end thicknesses added to 2 body thicknesses, plus the free space. In the new specifications, a matrix provides a seam thickness dimension for all combinations of material thicknesses. Tightness rating is the percentage of ironed out end hook below the worst wrinkle. Actual overlap is the amount the body hook overlaps the end hook. This is the secondary seal. Body hook butting is the length of the body hook relative to the seam length. It is expressed as a percentage to indicate the amount by which the body hook is embedded into the lining compound. Seam gap is the distance internally between the body and end components at the uppermost part of the double seam. This must be as small as possible. To ensure the critical parameters are acceptable, the operating parameters must be within the tolerances on the specification sheet. Seam length is one of these. The countersink depth. This is where the seaming chuck locates and supports the end. The body hook is formed from the flange of the can and the end hook from the curl of the end. The free space is the seam thickness minus the sum of the 5 material thicknesses. 0.13 mm is used as a nominal for free space and is the allowance for the compound. Evaluation should always be carried out on consecutive cans from numbered stations. Each head is an individual machine and could be misset. For the finished seam evaluation, 2 sets of cans should be collected, one for sectioning and the other one for teardown and visual assessment. Take the first set of cans, mark at least 2 diagonally opposite points on the seam, ensuring subsequent checks will be taken at these 2 points. Empty the can, rinse thoroughly and dry it as much as possible. Before measuring, the gauges should be calibrated using the setting pieces provided. The external dimensions, countersink depth and seam thickness, have to be measured first using the appropriate gauges. The seam thickness depends on the combined material thicknesses. The component suppliers provide the thickness of the body, but it will be necessary to measure the thickness of the end. Now, it is possible to section the can with the saw at the marked positions. This will allow for measuring the internal dimensions with a projector. With an appropriate tool, push the sectioned part of the seam into the can, exposing the cross-section to be measured. If it is necessary, clean the exposed cross-section with an eraser. The can should be placed on the projector and positioned to give the sharpest possible image for measurement. The section appearing on the screen will now include measurement lines. These should be checked for positional accuracy and manually repositioned as necessary. The results can then normally be automatically recorded. Any out-of-specification results will be highlighted, showing corrective action may be necessary. Visual inspection of the double seams should always be carried out. This is the only way to quickly establish signs of early tooling wear, gross misadjustment, or damage to the seamer tooling, for example cracked or broken chuck. Rotating the can whilst inspecting the bottom of the seam and the outside of the can will allow any cut or crack in the metal, including slivers or fine hairs, to be observed. Tilt the can and look into the seam area of the countersink wall to detect any dents or bulges. And finally, feel for any sharpness or rough edge in the top inside of the seam. To evaluate the tightness rating, use the second set of cans. It is necessary to tear the cans down. Remove the top of each can with an appropriate seam cutter and separate the end hook from the body hook. Inspect the inside of the top of the can for the chuck wall impression. If the seam is set too tight, the body wall could be fractured. The end hook should be carefully inspected for any sign of wrinkles. Look down on the end hook, which could show if there is any amplitude indicating a loose seam. The results obtained need to be evaluated. If any dimension is out of tolerance, another check should be done to confirm original findings. Seam thickness should be evaluated in conjunction with tightness rating, free space, and seam length. If a large seam thickness value and a low tightness rating is found, indicated by wrinkles and a high free space, this indicates a loose seam, which could result in leakage. In this case, the second operation roll should be tightened. A large seam thickness value and 100% tightness rating, indicated by no wrinkles but still having a high free space, can indicate the seam is over tight and has led to the seam springing apart. This is called a sprung seam. In this case, the second operational roll should be loosened. Any roll adjustment should be carried out at the peak of the respective cam. It is quite common to set seaming rolls clearances with the use of a feeler gauge. With experience, the correct feeler gauge can give the correct seam thickness. If the actual overlap is too low, there are 3 parameters or a combination of these that can be the cause: a short body hook, a short end hook, or a large seam length. If the body hook is too short on only one or two heads, the spring pressure on those heads should be checked. There are a number of different types of spring pressure gauges available for this check. Adjustments can be made to the spring pressure if it is found that the pressure is not within the target specified by the seamer manufacturer. Increasing the lifter spring pressure will give a longer body hook. If the body hooks on all heads of the machine are short, the pin height should be checked. To increase the body hook, the pin height should be reduced. The end hook is produced by the first operational roll. As the first operational roll moves towards the chuck, it curls more end hook into the seam, reducing the seam length. A resultant short end hook could be caused by the first operation roll being set too loose. A long seam length is caused by a first operation set too loose or a second operation set too tight. The body hook butting is affected by the body hook length and the seam length. If the butting is low, the body hook could be too short, or the seam length could be too long, or a combination of these conditions. The body hook not butting into the compound correctly could cause a leaking condition. If the butting is too high, the body hook could be too long or the seam length too short. Either or both of these faults could cause a split at the bottom of the seam. A high seam gap can lead to metal pickup and possibly leaking cans. Moreover, stacking cans with a high seam gap could result in leakage due to seam movement. For these reasons, seam gap is now considered a critical parameter. A high seam gap usually coincides with a deeper countersink depth. It is therefore necessary to correctly set the seaming roll height. The only way to do this properly is by using a roll height gauge. The gauge is put into position between the chuck and the lifter, then opened up to deflect the lifter down, thus simulating a can under load during seaming. The roll is adjusted down to lightly contact the chuck, and then raised to typically 0.076 mm for first operation and 0.152 mm for second operation. Since the introduction of 202 diameter, the industry has reviewed the double seam specification in relationship to improving seam integrity and reducing iron pickup. The basis of seam acceptability relies on the double seam meeting the critical parameters of seam thickness, tightness rating, actual overlap, body hook butting, and seam gap. These minimum requirements must be maintained under all conditions. Finished seams should be checked by complete teardown and sectioning method once every 8 hours for line speeds up to 1500 cans per minute and every 4 hours over 1500 cans per minute. For any further support or training requirements, please contact Customer Technical Services or Seaming Systems, or alternatively, the local CTS representative.